Hey, Trig Kits. Today we're starting chapter 4, graphing trig functions on Trig with Mr. Forbes. Notes out, and away we go. All right, we're going to start looking at graphing trig functions. We're going to do that several different ways. A lot of times we'll use our calculator to check, but we'll look at pencil and paper. We may even do a GeoGebra activity as we go along. We'll see. But here we go. We're diving into graphing trig functions. The graphs of trig functions are called periodic functions. Periodic functions are functions that repeat their values in a regular pattern. For example, sine and cosine, and you'll see that as we go through the notes. Another way to think of this, a classic example, a real life situation, is waves. I can't spell. So waves are classic periodic functions because they go up, they go down, they go up, they go down, up and down, up and down. So anything that's a wave is a periodic function. We're going to define then the pieces of the graph. The first piece we're going to look at is the period of the graph. The period of the graph is the length of a function before the values begin to repeat themselves. You might think of it as one cycle. So period is from start until it starts to repeat itself again. It's called the period. The period of sine and cosine come from the circumference of the unit circle, which is 2 pi. Therefore, the period of sine and cosine is also 2 pi. And we know that if we think about finding the coterminal angles have the same values as we go around the unit circle. And so that's our periodic function. Therefore, we can define mathematically a periodic function is a function f such that f of x is equal to f of x plus np for every real number x in the domain of f, every integer n, and some positive real number p. The least positive value of p is the period of the function. So let's look at the graph of the sine function. Graph of the sine function is any points on the unit circle that has coordinates cosine of s, sine of s. So remember, cosine is the x value, sine is the y value. And let's recall that as s increases, so we're thinking of the unit circle. So it might help you to pause and get your unit circle out to verify all of this. But as we're on the unit circle, we're going from 0 to pi halves, right? From 0 to 90. What does sine of s do? Sine of our angle. We're in radians with s. That increases from 0 to 1. What is cosine of s doing? Well, that's decreasing from 1 to 0. What if we look at pi halves to pi? Well, again, sine is the vertical part. We just went from 0 to 1. Now we're going from 1 to 0. So now we are decreasing from 1 to 0. Cosine is the x part. We just went from 1 to 0. Now we're going from 0 to -1. We're still decreasing from 0 to -1. From pi to 3 pi halves, what's happening? From 180 to 270. Vertically, we went from 0 to 1, 1 to 0. Now we're going to drop from 0 to -1. So we are still decreasing from 0 to -1. Cosine, though, we went from 1 to 0, 0 to -1. Now we're going to go from -1 back to 0. So now we start increasing from -1 to 0. And 3 pi halves to pi. Now we are increasing because we're at -1. We're increasing back from -1 to 0. And then we would start again. Cosine, we're at 0, so we are still increasing from 0 to 1. The domain for our function is -infinity to infinity, so we can go as far left and far right as we want to. Since it keeps repeating itself, the range is -1 to 1. And we talked about this in chapter 1. Remember, sine and cosine have to stay between 1 and -1. And so we'll see that in our graphs. Note also that the book will now use X instead of S, so we can graph them on the coordinate plane. And so that takes us to the graph of the sine function. Since y is equal to sine of x is periodic with a period of 2 pi, that comes from going around the unit circle. The domain is negative infinity to infinity. The graph continues in the same pattern in both directions. For the problems that we're going to do, the direction should tell you either we're going to graph one period, we're going to graph two periods, and we'll talk about that as we go through the lesson. A sinusoid graph is the graph of a sine wave function. And I'm going to briefly sketch this, and then we'll talk about where the parts came from. So here's a sinusoidal graph. Again, that's the graph of a sine wave. There are different types of waves. And so let's see where this thing comes from. So how do we get the graph of y equals sine of x? Well, we're going to take the values that we used on the unit circle, and we're going to plot those on a coordinate plane, and we're going to see what happens. So sine, remember, is the vertical distance. So it's sine at 0 degrees. There's 0 radians. We're at 0. Sine, the vertical distance at 90. Well, that's 1. The vertical distance at pi, or 180, we're back to 0. The vertical distance at 3 pi halves at 270 is -1 because we're down 1. And at 2 pi, we're back to 0. And that will match up with all of our increasing and decreasing, right? From 0 to pi halves, we're increasing from 0 to 1. Now we're decreasing from 1 to 0, decreasing from 0 to -1. Now we're coming back and increasing from -1 to 0. Well, now we're going to make a sketch of that graph. And to make our sketch, we're going to sketch an x-axis. We're going to sketch our maximum value, which is 1, and our minimum value, which is -1. Then we're going to plot out our main values. And so as we do our graphs, we're going to usually plot out the midpoint, the starting value, the ending value. So our starting value is 0. Our ending value is 2 pi. And then we want to plot the midpoint of those. Well, halfway between 0 and 2 pi, that's pi. And then halfway between 0 and pi, that's pi halves. And then halfway between pi and 2 pi is 3 pi halves. So we want to sketch the values of the graph at that point, because that's going to give us our critical values, our maxes, our mins, and our zeros. So now let's come back and plot those points. So sine of 0 is 0. Sine at pi halves is 1. Sine of pi is 0. Sine of 3 pi halves is -1. And sine at 2 pi is 0. And you'll notice then that makes a curve. And as we sketch this, we're just making a nice, pretty little curve. We want to extend a little bit on each end with arrows. Note at the max and the min, we want to try to flatten that out to make that a nice little curve, not a V-shaped thing. But there's our sinusoid curve. We're going to note that sine is an odd function. Remember, an odd function from college algebra is a graph that is symmetric with respect to the origin. So if we actually would continue this the other way, so sine actually goes on forever. We could keep graphing this over and over and over and just looks the same both directions. But if we look just at the origin, this is would be a 180 flip. And so that's our odd function, because that means for any ordered pair x, y, then -x, -y is also in the function. That's our rotation about the origin. So therefore, the graph y equals sine x is an odd function. For example, pi halves 1 and -pi halves -1 both belong to the function. Well, what about cosine? So we'll do the same thing for cosine. So we're going to start, cosine also has a period of 2 pi. So we're going to sketch starting at 0. We're going to end at 2 pi. Halfway between is pi, and then halfway between those, our quarter points, is pi halves and 3 pi halves. We're going to do the same thing, except cosine. Remember, cosine is now the horizontal value. And at 0, cosine starts at 1. Our horizontal value is 1. At pi halves at 90, our horizontal value goes to 0. At pi, our horizontal value is now -1. At 3 pi halves, our horizontal value went back to 0. And at 2 pi, we're back to 1. And so here's our cosine graph. Again, at the maxes and mins, we want to flatten out. There's our cosine graph. So that's different than our sine graph. Sine graph starts at 0 and goes up. Cosine graph starts at +1 and goes down. Now, there's will be things that affect that, and we'll look at that later on in the lesson. Cosine, recall, is an even function. An even function is a function with a graph that is symmetric with respect to the y-axis, which means if we bookfold this, flip it left and right over the vertical axis, we get the same graph. And you can kind of see that here. You'll get a better picture when we put this on your calculator, which means if xy belongs to the function, the negative xy also belongs to the function. The graph of y equals cosine x then is an even function. For example, pi halves 0 and it should be a negative pi halves 0. Both belong to the function y equals cosine of x. And let's look at graphing these on the calculator. So let's look at graphing sine on the calculator. Remember, we're going to use the Z trig window. And we're going to graph this in radians. So I want just y equals sine of x. And let's see what the graph looks like. Now I'm in radians. And so again, you can see here what's going on. There's a period from 0 to 2 pi. If we actually look at the window, it's graphing here from here to here. And we can change this if we need to. This is a little bit past 2 pi. That way we can kind of see how, but we want to zoom trig if we haven't already, which I think I was already there. And so you should be able to see there's the graph that starts at 0, goes to 1, 0, -1, back to 2 pi. It puts in the quarter points for you. But you can see it kind of goes left and right. If you zoom out, again, you're just going to see a whole bunch of sine curves. Here's our periodic function, just back and forth, back and forth, back and forth. Same thing over and over. Let's also look at the graph of cosine. So we'll look at y equals, instead of sine, let's look at cosine of x. And what does it do? So again, cosine starts at 1 and then goes down to 0 and back to 1. And let's intersperse those together and see what happens. I'm going to go back and put sine first. Let's look at cosine and see what happens. So here's our sine graph. And then here comes our cosine graph. You'll notice they're the same, but they're a little bit off. And in fact, we can notice how far they're off just by looking at their periods. Remember, all of these were pi halves or 90 degrees between the marks. So cosine and sine are off by 90 degrees. Why are they off by 90 degrees? Because they're co-functions, 90 degrees. Let's look at some more graphing things. The examples we're about to graph are stretched or compressed. And so again, this is the same idea that we used in college algebra. Compressed is shrunk, either vertically, horizontally, or both when compared to the graph of y equals sine x and cosine of x. So we're going to graph y equals 2 sine x and y equals sine x and compare them. So let's look at the graph of y equals sine x. We know that is 0, 1, 0, -1, and 0. Let's see what happens, and let's go ahead and sketch that. So that's going to go from 1 to -1, 0, 1, 0, -1, 0. And let's look what happens if we sketch a graph of 2 sine x. Well, that's going to take the value of sine x and then multiply it by 2. So sine of 0 is 0 times 2, that's still 0. Sine of pi halves is 1 times 2 is 2. Sine of pi is 0 times 2 is still 0. This is -1 times 2 is -2. 0 still gives us 0. So what happens with our 2 sine of x? Well, that starts still at 0, but now it's going up to 2, back to 0. Now we're down to -2 and back to 0. So what happens if we put a number in front of our function, a number bigger than 1? Well, that's going to increase the minimum and the maximum of the graph. And we're going to call that value amplitude. Amplitude is the value by which a periodic function is stretched or shrunk in a vertical direction. And we're going to call that value A. So amplitude is going to be the value A. So the graph of y equals a sine of x, or y equals a cosine of x, with a not equal to 0, will have the same shape as the graph of y equals sine x or cosine x, except with the range -a to +a. The amplitude is the absolute value of a, because we have to consider what happens if it's a negative, and we'll do that here in a second. The amplitude then of a periodic function is equal to half the measure of the difference between the maximum and minimum values. So if we looked up here, the maximum distance between 2 and -2 was 4. If we divide that by 2, we got 2, which is our amplitude. So the amplitude of y equals sine x or y equals cosine x is 1, because there is no value in front. We're going to assume that's a 1, a coefficient of 1. How would the graph of y equals 1/2 sine x compare with y equal sine of x? Well, that would be a shrink by 1/2 in the vertical direction. No matter what the value of the amplitude, the periods of sine x and cosine x are still 2 pi. So let's add another variable into the equation, and that is y equals a sine of bx. So now we're looking at this number b here. And so for example, we're going to graph y equals sine of 2x and see what happens. So this says, instead of taking the value of the sine and double it, we're going to double the angle first, then get the sine value and plug it in. So it's a different place where we're putting the 2. So let's see how that works. We're going to take 0, and we're going to double 0. Well, that's still 0. So sine of 0, well, that's still 0. For pi halves, we're going to double the angle, and therefore we get pi. And so sine of pi is 0. We're going to take pi and we're going to double pi. Double pi would be 2 pi. Sine of 2 pi is 0. We're going to take 3 pi halves and double it. That gets us 3 pi. Well, sine of 3 pi is 0. And take 2 pi, double it is 4 pi. Sine of 4 pi is 0. Now, it looks like it'd be a straight line, but we know it's a periodic function. And so now instead of going from 0 to 2 pi, we're going from 0 to 4 pi. And then we would have pi, 2 pi, and 3 pi. Our amplitude is still 1, so we're going from 1 to -1. And what do we know? Well, we have to be at 0, be at 0, be at 0, be at 0. We know sine has to start at 0 and go up. And so it's got to look like this to hit all of those 0 points. And so what did we just do? Well, we just completed our period from what? From 0 to 2 pi, there was our period. So how many times did it take for us to go around? Well, we actually did 2 full laps instead of 1. Why did we do 2 full cycles, 2 full periods instead of 1? Because we doubled the angle. And so if we double the angle, that means we're going twice as fast, we're going twice as fast around the circle. And so this has to go through its cycle 2 times. Therefore, we're going to define that as the period length of sine and cosine then is 2 pi over b. So period, so we're going to say P is equal to 2 pi over b. B is the number in front of the angle. I'm not on the screen. If b is greater than 1, a horizontal shrink occurs. And the reason that happens is because as we go faster around the circle, then it takes us less time to complete a period. So it's a shrink. If we make b a smaller number, it's going to take us longer to complete our cycle, and that's going to be a horizontal stretch. And so let's look at some examples. Let's look at the graph of y equals cosine of 1/2 x of 1 period. So again, we're using our formula. Y is equal to a cosine of bx. So what do we know? Well, we know our amplitude is 1. We know b is 1/2. That's going to tell us how to get our period. We know period is equal to 2 pi over b. Therefore, we have, if we plug in the 1/2, that gets us 2 pi over 1/2. We're going to flip that sucker and multiply. P then is 4 pi. So we're going to go from 0 to 4 pi. And so let's see what happens here as we graph. So if we look at 1/2 x, so 0, we're looking at half of 0. Half of 0 is still 0. Cosine of 0 is 1. We're looking at half of pi halves. Well, that's pi fourths. Cosine of pi fourths is root 2 over 2. Half of pi is pi halves. Cosine of pi halves is 0. 3 pi halves, half of 3 pi halves is 3 pi fourths. Cosine of 3 pi fourths, now we're in the second quadrant, is negative root 2 over 2. And half of 2 pi is pi. Cosine of pi is negative 1. And so let's see what happens. So here we actually had, and we're not going to graph like this in the future. We're just kind of seeing where the stretch and the shrink occurs. This was, well, this turned into, which was pi halves, pi, 3 pi halves, and 2 pi. But they changed because we took half of the angle. That changed this into pi fourths, pi halves, 3 pi fourths, and pi. Still have an amplitude of 1 and negative 1. This is cosine. Cosine starts at 1 and goes down, but it goes down to be 0 at pi halves, not pi fourths. So there's our root 2 over 2. Negative root 2 over 2, negative 1. So you can see, because the number we had is less than 1, what did it do to our graph? Well, it stretched it out horizontally. In fact, to finish this graph, we would need to go to, we need to continue this line. And so we're going to continue this at, this would be 5 pi fourths. 3 pi halves, 7 pi fourths, and 2 pi. To finish our graph, that would be negative root 2 over 2, 0, root 2 over 2, and 1. So that finishes our graph. But notice that was our altered angles. Our actual angle where we finished is 4 pi, and that was the number we got from doing the period. So as we're doing our graphs, we're actually going to use this value to figure out our points instead of finding the modified angles. So here's our steps we're going to use when we sketch a graph. We can sketch a graph quickly if we divide the graph into 4 equal parts. One method is to divide an interval into 4 equal parts as follows. We want to find the midpoint of the interval by adding the x values of the endpoints and dividing by 2. As we start here, most of the time it's going to be easy numbers. Later on, when we get to phase shifts, it's going to be a little bit different. But for now, it should be pretty easy numbers. The second method is to find the midpoints of the 2 intervals found in step 1 using the same procedure, and that was just split in half. These intervals will give you the maximum points, the minimum points, and the x-intercepts. That's why they're important values. So let's look at an example of doing all of this together. Example 4 is a graph. Sketch the graph of y equals negative 3x sine, negative 3 sine of 4x, and we're doing that for one period. The first thing we're going to do when we're sketching a trig function is identify our parameters. And so what are the values that we have? Our amplitude is 3. Note that amplitude is always positive. However, amplitude is also a negative 3 because the value is negative, again, from college algebra last semester. That means the graph is reflected. So because we have a sine graph, we're still starting at 0, but instead of going up, we're going to go down because it's going to be a reflection of the graph. B is 4, and that means our period, which is 2 pi over b, becomes 2 pi over 4, which is pi halves. So the graph is going to repeat itself in pi halves. So that means the graph will start at the origin and go down because it's negative instead of up. Our left endpoint, where are we starting? Well, we're still starting at 0, and pretty much all of these graphs will start at 0 until we get to a phase shift. We're going to end at the right. We're going to end at the right endpoint, and that's our period. That's pi halves. From there, we can figure out our other quarter points. The midpoint, well, what's halfway between pi 0 and pi halves? That's got to be pi fourths. And then what's the quarter points between those? Well, halfway between 0 and pi fourths has to be pi eighths. And this would be 3 pi eighths. So on our sketch, then we have our amplitude. The highest we're going to get is 3. The lowest we're going to get is negative 3. We're starting at 0. And we're going, our quarter points are pi eighths, pi fourths, 3 pi eighths, and pi halves. And that's pretty much all we need to sketch our graph. We know this is a sine graph, but it's a reflected sine graph. It has to start at 0. Then it's going to its minimum first because we reflected it, back to 0, then the maximum, and down. And then we can always check these by checking them on our calculator. Again, we're going to put arrows. We're going to go a little bit past the points to show that this continues. And we can put this on our calculator to see what happens. Let me clear these other ones out. So we have negative 3 sine of 4x. Now again, the calculator is not going to look the same as what we graph, but you can get the general idea because we'll typically use the same graph. But here you can see the graph starts at 0. It goes down to negative 3, goes up to negative 3, and back. And if you can tell, it did that in 90 degrees. So 2 pi is here. And so there's pi halves, 90 degrees. There's 180. There's 270, and there's 2 pi. So you can use your calculator just to kind of check and make sure you're getting this general idea. Let's look at another example. Y equals 2 cosine pi halves x, but we're going to graph this one over 2 periods. Again, our general formula is y equals a sine of bx. First thing we want to do is identify our parameters. Our amplitude is 2. Our b is pi halves. So that's a little bit different. Therefore, how do we find our period? Our period is 2 pi over b. Our b value is 2 pi over pi halves. Again, we're going to flip that sucker and multiply. And so we're multiplying by 2 over pi. Well, what happens? Well, the pi's cancel, and we're left with 4. So we have a period that has no pi. So this is in non-pi radians. We're still in radians, but we're in non-pi radians. And so this is going to be for our first endpoint. The left endpoint is still 0. Our right endpoint, we're stopping at 4. Therefore, our midpoint has to be 2. Our First quarter point is 1. Our third quarter point is 3. Our amplitude is at 2 and -2. I'm going to add in values here on this graph. So here is our 0, 1, 2, 3, and 4. And then we're also going to look at the second period here in a second. This is a sketch of the graph of cosine. Cosine starts at its maximum and goes down. So we start at 2, we're at 0, we're at -2, 3, we're back to 0, 4, we're back to +2. So there's our one period. And we want to do that again. Well, to do that again, we're just going to repeat the process. Notice the endpoint of the first period is the same as the first left endpoint for the next period. So we're starting again at 0, at 2. At 5, we're back to 0. At 6, we would be back to -2. At 7, we're back to 0. At 8, we're back to +2. So there is completing our 2 periods for the graph y equals 2 cosine pi halves x. When pi is in the argument, note it will not be on the x-axis when labeling it. Notice we had no pi's here because it will cancel out with the pi in the numerator when dividing. That's what we got when we did our flip that sucker and multiply. The x-intercepts are real numbers in radians. We'll look at one more. Graph y equals -2 cosine x over the interval -2 pi to +2 pi. Go ahead and pause the video, see if you can do this somewhere yourself, and then come back and check and see how you did. So again, the first thing we want to do is establish our parameters. Our amplitude is 2, but note the graph is reflected. So we're going from 2 to -2. Our b value is 1, so our period is 2 pi over b, so our period is just 2 pi. First, we want to find the points 0 to 2 pi. Then we're going to take the opposite of them for -2 pi to 0. All right, so we're just going to basically continue the graph in the other direction. We're going to start then, our left endpoint is at 0. We're going to end at our period, which is 2 pi. That means we're using our regular quarter points, pi halves, pi, 3 pi halves, and 2 pi. This is a cosine graph, but it's negative. So that means we flip it. So instead of starting at our positive maximum, we're starting at our minimum maximum. So let me go ahead and label this. This is 0, pi halves, pi, 3 pi halves, 2 pi. And so that means we're going to 0 to +2 to 0 back to -2. And because cosine is an even function, we're just flipping all of the points over. And so this would be -pi halves, -pi, -3 pi halves, -2 pi. And we're just continuing our pattern. There's the flip, 0, flip pi, flip, -3 pi halves, and flip. So here is the sketch of our cosine graph. Again, you can use your calculator to check it. The graph of y equals -2 cosine of x. All right. Homework for section 4.1 is going to be page 153. We're doing problems 1 through 12, 14 through 52 evens, 55, 57 through 64. Have a good day, Maroons. See you in class.